In our previous tutorial, we learned how to append a range of data into another Google Sheet tab and put it down the bottom of that range with our append data function. In this tutorial, we're going to learn how to do the same thing, but in the condition where there is other data that rolls down the rest of the page. In this example here, we have a bunch of rolling totals that run all the way down the rest of the page. If we were to apply the same approach that we had to our previous tutorial, then that data will be appended below row 30. Now, we don't want that. Let me show you what I mean. So I'm going to hit this sheet A1, hit Control C, and I'm just going into our old sheet name destination here. So this is our first example, and hitting Control V, and then hitting save. And then I'm going to just hit run. And you can see that data has been appended down here instead of where we want it up in row 19. Not ideal. Now, if you want to play along, and I encourage that you do, there is a link to the starter sheet in the description below. Go ahead and make a copy of the sheet and then head over to extensions and head into App Script. Now, if this is the first video in the series that you've seen, you won't see this full filled out function up the top here. That's okay. We can go down here and you can pause and see if there's any changes as we go along. Great, let's get started. So scroll down until you find the append data to here. And already I have prepared the sheet name source and sheet name destination for you. We're going to fill out the rest together. So not much has changed initially. First, we're going to create our constant SS equals SpreadsheetApp get active spreadsheet method here, which we'll call the spreadsheet. Then we want to grab the sheet source and the destination source. So const sheet source is equal to ss.get sheet by name, and that name is going to be the sheet name source. And let's just duplicate that, and I just hit Control Shift and down arrow to do that, and we should have this source here and this source here. So I'm just going to select this first one and hit Control D, and that'll select both these two source words here, and I'm going to type in destination here. Okay, so this one's not being read, so there's a spelling mistake there somewhere. Sheet name destination. There we go. Rock and roll. Fix that one up. Cool. And now we need to retrieve our data. So not much has changed in our data retrieval. So retrieve data. Const. We're going to grab the last row source. So last row source is equal to sheet source dot get last row. And if you want to know a bit more about getLastRow, you can go back to the previous tutorial. Oh, we got list. Let's make it last. That's good. Const. Let's make another one. Now we need to grab the range source, and that's going to be equal to sheet source dot get range. And here we'll use template literals. That's the string with the backtick. So we can add in a variable. So we'll say A2 colon D, and then we'll say $ curly braces last row source. Nice. As I mentioned before, there's other ways of handling this. GetRange allows you to put in numbers as well. So it'd be the start row, the start column, and then the length of the row and the length of the column. Next, we'll go const again and say values. We'll grab those values of the source, and that's going to be range source dot get values. Don't forget to add the one with the S to get the entire range. Now, just like in the previous tutorial, you can use the optional range source clear content. We won't use that in this tutorial because we are testing. But if you want to use it, just uncomment it and it's good to go, and they'll clear the content in this incoming data file here after it's been submitted. Nice. Okay, so now we need to paste the data. This is where things change a little bit, or append the data. Oops. So we're going to look at two examples of getting this last row in this main sheet one this time around. One is a programmatically simple approach and the other one's a little bit more complicated, but if you've got a huge amount of data, then the second approach is much, much faster. So let's look at our example number one. In both examples, we are going to first get this column A here, and we're going to review that and to find out where this first empty row is. So let's create a constant variable called range dest col A is equal to sheet destination dot get range, and we want the entire range. So all the way from the top all the way down to the bottom. So it'll be A colon A. Okay, so now we're going to create a constant variable called first empty row in that column. And this is going to call a function that we will generate. So we've predefined a function down here called first empty row. So that's the one we want. So we'll say first empty row. And you can see that it requires a range. Well, we've got the range up there. So range destination column A. That's the one that we're going to call. Okay, so now that we have that range, let's jump from here before we complete this function and go down to this first empty row function. Okay, so as our notes say, it's a simple search function. Search reverses the array to ensure that any title data is not detected, and then findIndex is used to find the first cell that is not empty. If all rows in the sheet are full, then we just add one to the row, and then we're going to return a number. Cool. So in this function here, we're going to first grab the values from the range. So we'll say const values is equal to range.getValues, and that'll grab our list of values. And then we've got const length is equal to values.length. Okay, give that cheeky little console log, and let's log both the values and the length and save. Let's go up here and click on this append data v2, and we should see this console log here. So let's go ahead and run. Awesome. So down the bottom here, we see it says it has 30 rows in this entire sheet tab, which is correct, 30 here. And then it gives us the array of all the values in the first column. Nice. Okay, so now let's go const index equals values. And now we're going to use some functional methods here to help us. So we are currently in a 2D array. So if you have a look at the execution log, we have a 2D array or a matrix here. And we don't really need that for our purposes. So we just want to get rid of this outer array. Fortunately for us, Google Apps Scripts and in turn JavaScript, of which it is built upon, has the flat method here. So we're going to create a new line, hit tab, and use the flat method. Now you won't see any hints for the flat method, but it is indeed there. And then we can chain onto that the reverse method. Okay, and that will reverse the array or make it go in the opposite direction. From there, we can now deploy the findIndex method here, which will get us the index or the position of the first value that contains something. So the findIndex method takes a function, and we can create an arrow function here. We'll set the argument to row and put in our little arrow indicator for the function. And then we'll say if the row does not equal blank, then we'll return true. So it'll return true, and then it'll give us the index. Now, because we reverse the row, we need to subtract the length of the values by the current index and then add one to it. So let's create our constant variable here called row now. And then we need to have it equal the length minus the index. Now, keeping in mind the index starts with 0, so it goes through 0, 1, 2, 3. So we need to then add 1 to it. And then we'll return the row and hit save. Cool. Let's go up here. We could console log this to test it out. So console.log first empty row. And we'll hit save and give it a little test. Okay, so 19 should be the first empty row. It is indeed 19. And now we can continue as we had before with our previous tutorial. So we can say const new last row equals first empty row plus now value source. So that's our source values, these ones in incoming data. And we're going to get the length of them. Dot length. And we will subtract 1, otherwise it will be too large. And now we'll grab our range, so const range destination is equal to sheet destination dot get range, and then backticks a $ curly braces first empty row colon nil colon d $ curly braces new last row, and then finally range destination dot set values braces, and then we're going to put in our value source. Control here and then Control V. Hit save. Okay, let's go to our main sheet and we'll hit run. And you can see that's been added in. If I hit run it again, that'll get continue to add in. If we run out of space on the page, no worries. It'll just add in some more. Okay, let's say we don't have any data in here. We'll give it a little test to make sure lots of conditions are met. Hit run again. And that's also been added in up the top. No worries. Okay, so let's just copy this back in. Control C, Control X to cut, and Control V to paste. Cool. Run it one more time just for fun. We are good to go. If you only have a small bit of data, maybe up to 5,000 rows, this is probably an okay approach, but it does slow things down if we do have a large row limit. Fortunately, there is another more efficient approach to handling getting this last row, and that's with the binary search. Okay, so let's go up here, and we've got this first empty row here. We're going to Control Alt and down arrow to duplicate it. Go arrow back up to the next one and Control / to comment that out. And then we're going to replace this now with a get first empty row binary search function here. And you can see that's appeared there because we've got the start of this function down below. Now we can see it takes a range, so we can still use that same range. So range destination column A. And then it's also going to take a header row, which we haven't generated yet. Header row is going to take some text in it. So let's put this up here with all our other text items. And we'll say const or header rows, we'll say destination. And let's have that equal to the number of rows in our header. So for us, that's going to be 2. Cool. All right, so now that we have that variable, we can put that in here. All right, so we've got this function ready to go. Let's go ahead and build our binary search. So binary search is a little bit weird. The way it searches for data is first it'll go halfway between the two data, rounded down, so halfway between 3 perhaps and 30. And it'll look at this, I don't know, what's that, 13, I guess. And we want it to see if this row is empty. And if this row is empty, the previous row needs to have some text in it. Now, if that's not the case, in this case it isn't, it's going to jump over and then halve between 14 and 30. So somewhere around here, for example. And if this row is empty, then it's good. It'll check this row. And if this row has data in it, then that's the last row. Well, in this case, it's not the case, so we'll halve again, and it'll keep halving until it finds the correct location. Unlike the previous way we did things, is where we reverse this entire array here, and then iterated on each line, checking each line to see if we found the right location. So it significantly reduces the amount of searches that it needs to find where it's meant to go. Okay, let's build it. So we'll create a variable here, const values, just like before. And that's going to equal our range. And we'll say get values again. And then we'll apply just flat to it. Then we also need our length still. So we'll say const length equals values dot length. And here's where it gets a bit different. First, we need a starting value. So that's going to be, we'll say let, because it may change. Let start equal our header rows. And then we'll say let end equal our length -1. And this will help us iterate through things and calculate our next location. Let's go ahead and make a note in here. Okay, so before we start our binary search properly, we want the condition if this entire range is full. So for example, Control-C, Control-V, Control-V, then this entire array that we've collected here is full. It won't be able to recognize the first empty cell and then the previous one. So we need to check this last value first, if that makes sense. Okay, so let's go ahead and do that. So if values end does not equal blank, then all we want to do is to return the end plus 2. And I've just noticed here my usual habit of spelling length with the H and the T back to front. So I'll hit Control and D, H, saved yourself from an error. So our end here needs to be +2. What's that mean? So right now, this is going to provide us the length of the array, not necessarily how many values there are in the array. So keeping in mind that array starts at 0, so that's why we subtracted 1. But we want the length past the current length of the array. So that means we need to add 2 to end. Cool. Now we can start our binary search while loop. Here we're going to use the while loop, and that has a start. And we're going to say if the start is less than or equal the end, let's do the thing. And the first thing that we need to do is find the middle value of the existing numbers. Okay, so we'll create a constant variable, and this will stay constant within the while loop. So const mid is equal to math.floor, and then we're going to put our start. We want the sum of the start first before we divide it by 2. So start plus end, and then divide that by 2. Cool, and that will get us halfway. And floor means basically if it's on a decimal, so I don't know, 18.5, then it'll round down to 18. Okay, so now that we've got our midway point, we need to check if the cell is blank, the current cell we've iterated on is blank, and the previous cell has a value in it. So if values, square brackets, mid, so that's our mid value, so we're checking that midway point, is equal to blank, and the previous value, so values mid -1 does not equal blank, then we found it. So we're going to return the mid. Now keeping in mind, this is a 0-based iteration, so we need to add 1, so +1. However, if that's not the case, so if both the current and previous cells are blank, for example, then we restart our search from the bottom half of the array. So say else if values mid equals blank and values mid -1 also equals blank, then we just need to update the end. So end will now equal mid -1, and then it will start the iteration from that range. So that means once it halves, it'll start looking at this half of the information here, this half of the array here. Otherwise, so else the start, so if there is data in both the current location and the previous location, we'll say start equals mid +1. We'll hit save. Cool. Let's just go up here and just console.log mid, just so you know what's going on. Hit save. And how about we add in that value that's there as well, just so it's super duper clear. So values, mid. Okay. What we might do to make our testing a little bit clearer is let's go up to this console log here, and keeping in mind that we're iterating through a 0-based array. So this row 1 is going to be 0. This row 28 is going to be 27. And that might be a bit confusing. So let's make it a bit clearer for ourselves in our console log. And let's just update it with a row. It's going to be equal to mid plus 1. So the dum-dums like me can actually see what's going on. Let's hit save now and give it a bit of a magical test. So make sure you were on Append Data version 2 and hit run. Cool, and everything was added perfectly. So what's happened here with our binary search? So the first time round, it has halved the data. It's between 1 and 28 to row 15 here. It's gone to 15 and had a look and gone, hey, there is data in there. That's no good. We actually need an empty cell. So it has decided that the new starting point is going to be the mid plus 1. So there's 16. And it's going to go through the while loop again and then find the mid by adding 16 to 28 and dividing it by 2. And that's going to make the new point 22. So that will land right about here. Now this row 22 at the moment has data in it, but beforehand it didn't, right? So this was empty. So this row 22 was empty. So I was like, okay, empty, that's good. But in our next evaluation, we need to check whether or not there is something in the cell above, in the row above. And there isn't, so it would have been empty. So both these rows would have been empty, so that's not what we're after either. So in that case, when it evaluates down the end, it's going to make the new end the midpoint and minus 1. So this 22 minus 1 is 21. So now it's going to evaluate between 16 and 21 to find the midpoint, which ends up being 18. And 18 is so close at this stage. So close, but it's not quite there. This needs to be empty and this one has to have a value in it. So then it evaluates again, goes all the way through and looks at row 20. So row 20 would have been empty, but row 19 wouldn't have a value in it. So it halves it again and finds row 19. Row 19 doesn't have a value in it, but ding dong, row 18 does. We found our point. And so it records row 19 as our desired point. We made it. Well done. So these are our two possible searching options. As you can see, we're not iterating through every single line here. We're iterating through the points as we're halving our rows. As you can see, the binary search is much faster in iterating through the areas. It's not looking at every single row as it goes through from 3, 4, 5, 6. It's only looking at a few of them until it finds what it needs to find. Let's test the next condition. So we'll just run it again. Bink. Great, it appends underneath. All right, so we've got 2 more spaces here. Let's see what happens. Okay, we do our iteration through it, finds it again. Awesome. Okay, so we're down the bottom here. So in this situation, it should just look at this value here and stop. Let's see what happens. Cool, 31, done. Just adds it into the bottom. Perfect, that's exactly what we needed. Okay, we've got one final testing measure here, so let's just delete those out. And we need to go up here and just Control X and go to G, Control V. I've got no values in here. Let's see what happens. So it does it search again and adds everything to the top. So we know that's successful here. The only changes here is we've got some date formatting changes, which we could probably handle for. But let's not do that this time. Cool. All right, one more time just for fun. Excellent. Okay, binary search is pretty damn fast. As you can see, it's not iterating through every single row as you go. And if you've got thousands and thousands and thousands of rows, then this is going to be a much faster approach. However, there are some downsides to the binary search that we may need to handle for. Let me give you an example. Let's preview our next tutorial by heading over to main sheet Alt+2. And if you have a look over here, we've got some empty cells here that might make it a little bit challenging for us to use our binary search. Let's take a look. Okay, so let's apply this to this one. So I'm going to double click the Sheet tab, hit Control C. Let's close this and head back up to our function, append data version 2, and just replace this here, Control V, hit save. Let's go ahead and give it a run. Oh, that's strange. It has landed in this row 17 here, but we needed it to land in row 19. So what's happened? Well, if we Control Z, we go back, we can see is looking at these blank spaces and found this first blank space here to be up here, which is completely wrong. So we need to be able to handle for the entire range to see if there is a value here that might be appropriate. And that's what we'll be covering in the next tutorial. So if you want to get a notification when the next tutorial comes out, hit that notification bell. And if you've enjoyed this tutorial, please like and subscribe. Until next time.